just looking at them or if there's a better way to do this. Anyway, Elizabeth, we're back here. Just dealing with this. We get the y alone. What do we do?
You put 4 on the right side.
Okay, so that means we subtract 4. Now, be careful. Next line.
Divide by -1.
And we get?
Y is less than 1. -1.
Awesome. She remembered the reverse inequality symbol, okay? That was key. We have parentheses here. This one?
Oh, you would subtract 4, and then you would, yeah.
Okay, so we're there. We have y is between -2 and 4, and y is less than -1 or y is greater than 3. So I'm going to graph both of these using Joseph's method here. I'm going to graph this. I'll do that in black. It's from -2 to 4. And I'm going to put it up a little bit high because it's temporary. So that's that. You agree with that, Elizabeth?
Yes.
-2 to 4, y is between -2 and 4. Now this is saying y is less than -1, so I'm doing it in red. Y is less than -1, or y is greater than 3. Now we have an and, so the final answer is what? I give Elizabeth first shot. This is hard. I give her first shot. Just can you describe to me physically what belongs in the final answer? We want all the x's, all the y values that work. This is a y line. We want all the y's where this is true and this is true, which means this has to be true and that has to be true. Means it's got to be on the black and it's got to be on the red. It's got to be on both. It's called intersection of the sets. And intersection. We'll learn and is intersection, or is union. So you want to take a shot, or I can open it up? No? Volunteer? Josh?
It's -1 to -2.
-1 to -2?
Yes.
Between there?
Yeah.
Good.
And then on the other side, 3 to the 4. Yeah.
Good. So there is a graph of the answer, and algebraically we would write -2 is less than y is less than -1. We have 3 is less than y is less than 4, and I'm missing a word, and a lot of students have trouble with this because they're thinking in their minds the solution's this and it's also this. But as we describe what y needs to be, we just say the final answer for y is it's this or it's that. Because if there was an and there, what numbers work? What numbers are here and here? None. There'd be no solution. We want all those in there. Excellent job. Excellent job. Next one is 36. Similarly difficult. Who's up next? Emily. Emily, 36. Lucky you.
Okay. The quantity of x is less than or equal to x plus 4 over 3 plus 2, or x is greater than or equal to 2x minus 1. And 1 is less than or equal to x minus 1 over 2 is
Say
less,
all over 2.
all over 2 is less than or equal to 3.
How'd I do?
That's right.
It's good? Okay, so let's start cleaning it up right here. I don't like the 3. How do we get rid of this 3?
Multiply.
So 3x is less or equal to x plus 4 plus 6. Multiply everything on both sides by 3. Did I write that correctly? So we multiply everything by 3. That becomes 3x. This is triple a third, so it's gone. And triple 2. Okay? Or how about negative x is greater than or equal to -1? You good with that? And I'm going to multiply everything by 2. 2 is less than or equal to x minus 1 is less than or equal to 6. Okay, next line right here.
2x is less than or equal to 10
That means x,
is less than or equal to
awesome. Or, what's this become?
x is less than or equal to
She reversed the symbol. When you multiply or divide an inequality by a negative number, you must reverse the inequality symbol. Excellent. And something else is true. I can clean this up.
3 is less than or equal
So seems a little easier. 1, 2, 3, 4, 5, 6, 7, 8. Looks like 5 was a number, 1's a number, 3's a number. That should handle all the numbers. There's no negatives there. This one, how do I graph this one on the left?
Closed circle at 1,
Okay, at 1,
going to the left. And closed circle at 5, going to the left.
the net result,
X is less than or equal to 5.
yeah, this ended up, excuse me, but I'm just gonna throw a slash through there. It just wasn't helpful, okay? If we did the problem right, I don't wanna erase it, because I might have messed up. I wanna be able to trace my work in case I compare with someone, I'm not getting the same thing. So don't erase your work, but throw a slash through it if you find out it wasn't useful. Over here, I'm gonna do this in black.
Closed circle at 3, going to the right.
How far?
Until 7, because
And we quit. X is between 3 and 7 inclusive. X is between 3 and 7 inclusive. We include both ends. Final answer to this problem.
anything between 3 and 5.
That's what you said. It's not what you meant though. You said anything between 3 and 5. You want to say anything between 3 and 5 inclusive. When you do that, it includes the endpoints and makes this solid. Final algebraic answer? 3.
3 is great.
We're going this way, so this is less than this is less than this. Moving on now, it's always going to be less than or equal.
3 is less than or equal to X is less than or equal to 5.
Okay, sometimes these problems say solve, that's all you need. Sometimes they say graph, this is all you need. Sometimes it says solve and graph, you need both. You guys understand solve and graph? Okay, awesome. Yes?
Where did the 1 go? It said that X is less than or equal to 1.
When we had, the numbers had to be less than or equal to 5 or less than or equal to 1, that covered them all. This wasn't helpful information. It was like the very first one here. Well, more like this one right here. If X is less than -2 or X is less than 3, all you have to do is say X is less than 3. Someone says, what happened to that? Well, we already covered it when we said X is less than 3. So did we get the numbers that were less than or equal to 1? We sure did. When we took all the ones less than or equal to 5, we did. It's not like we're discounting them. We just don't need to mention them again.
Okay.
Okay, let's try to knock out these problems in 2, 3 real quickly to give you some time to work. I know you have something to do today, so let's knock these out. Okay, who's up?
Bailey.
Bailey, 2.3, number 3. If you get called on a third time in class, you're done. You don't have to do 1, 3. Go ahead.
The length of a rectangle is 5 centimeters more than twice its width. Find the largest possible width if the perimeter is at most 64 centimeters.
Did you say 64?
Yes, sir.
Okay, so she said, and I wrote down, I did some translating from English to math. She read the English, I wrote the math. She said the length of a rectangle was 5 more than twice its width. Is that correct? Is that what you said?
Yes.
The length is 5 more than twice the width. So I drew a rectangle. I just called the width W, and I made the length 5 more than twice the width. You can say L is that. I just wrote the 2W plus 5. We were told that the perimeter is less or equal to 64. Well, how do you get perimeter from length and width?
You have to square them together.
Add them all up. So we have a W and a W and a 2W plus 5 and a 2W plus 5, and all that has to be less or equal to 64, and we can solve that and get W. Okay, I'm not going to do the solving, but we're doing the setting up. Okay, number 5. Who's next?
Julia.
Julia, 5.
Find all sets of 3 consecutive odd integers whose sum is between 20 and 30.
Is this right? N plus 1, N plus 3 for odd integers? No, odd integers are 2 apart, just like even ones are. So here's 3 consecutive odd integers, and what they say the sum has to be, so I add them up, that's the sum.
Between 20 and 30.
So it's between 20 and 30. This becomes 3n plus 6, and
Subtract 6 from both sides.
then what?
Divide by 3.
So this is 14/3 is less than n is less than 8. So what could n be, the first number? There's some items n could be. It could definitely be 7.
7.
Let's do this as a mixed number. What's 14/3 as a mixed number?
4 over 2/3.
4 and 2/3.
Yeah.
Okay, so n could be 7 or n could be,
Anything between 4 and 2/3.
and it has to be an odd integer, remember?
Oh, yeah. 5.
Anything else?
No.
What was the, read what they want us to find at the end.
Between, whose sum is between 20 and 30.
Find what, whose sum? Find,
Odd integers, whose sum is between 20 and 30.
okay, you gotta
Find
back
all
up
sets
even
of
more.
3 consecutive odd integers.
Bingo, all sets. So the answer is gonna be 5, 7, 9, 7, 9, 11. These are sets. And we found them all. Because the lowest guy was 5 or 7, but the numbers are it, add 2 more. Okay? That's how we do that. 2.3, number 9. Waiting to hear you call it a name.
Would be me.
It would be you. 2.3, number 9.
Sides AB and AD of a square are extended 10 centimeters and 6 centimeters respectively to form sides AE and AF of a rectangle. At most,
Okay, hang on a second. I gotta extend, so I'm gonna put the A and B up. And here's C and here's D. And they're extended to get AE and AF of a rectangle. This was a square, and we extended AB, we extended AD to get AE and AF to make some rectangle. Looks like a square, not anymore. Okay? Go on.
at most, how long is the side of the square if the perimeter of the rectangle is at least twice the perimeter of the square?
Find at most x if what? What's true? The perimeter of the rectangle?
If the perimeter of the rectangle is at least twice the perimeter of the square.
At least means it's greater than or equal to twice the perimeter of the square. Now, what they say we extended? Did they say we extended a certain amount?
AB and AD are extended 10 and 6 respectively, so AB would be.
Okay, so this is 10 and this is 6. So up here, what's this length?
X plus 10.
Awesome, that's x plus 10. And what's this length?
X plus 6.
X plus 6, clearly not drawn to scale. Okay? What's the perimeter of the rectangle? You don't have to give me a final answer. Give me an
2x
expression.
plus
2 of these x plus 6s plus 2 of the x plus 10s, right? And what's the perimeter of the square?
4x.
So we have twice the perimeter of the square, which is 4x, and you solve. Now, if you have any difficulty with these word problems, it's usually going to be with what the symbol should be. Just solve it for the equal case. That's going to be the boundary. Find the boundary and then use your head. Should it be, is the boundary, could it be bigger, smaller? Think about that. So that's good enough on that. And let's just do the quick setup on these last two. So we're reviewing all sorts of word problems that you've done in the past. Just trying to review them. It's just a review. 13?
Joseph.
Joseph, 13.
Okay. A subway train makes 6 stops of equal length during its 21-kilometer run.
Okay, now look what I'm going to do. I'm going to have a 21-kilometer run. So this is 21 kilometers, making 6 stops. 1, 2, 3, 4, 5, 6. Does that include the end? Nah, we don't, we want. We got 6 stops during the run, just during the run. So those are the stops. Keep going.
The train is actually moving for 20 minutes of the trip.
The time moving equals 20 minutes, which is a third of an hour. They've been tricking me with that, so I want to think about hours. Yeah.
At most, how long can the train remain at each station if the average speed for the trip, including stops, is to be at least 36 kilometers per hour?
So we're going to not worry about that it can be greater than or equal to 36. We're going to just look at it being 36. And we're going to see what the stops could be if the average speed is 36. And what you have to understand, and you might not know it, is the average speed, you take the total distance traveled divided by the total time. That's the average speed. So in this case, it's pretty easy. The total distance traveled is 21, but the time is going to be, now, did they say anything? Let me see. Read it again. I feel like I'm missing something. Go fast through the whole thing.
A subway train makes 6 stops of equal length during its 21-kilometer run. The train is actually moving for 20 minutes of the trip. At most, how long can the train remain at each station if the average speed for the trip, including stops, is to be at least 36 kilometers per hour?
Okay, the time moving was a third of an hour. So the total time spent was 1/3 of an hour moving plus 6 times x. X equals length of stop. Do you agree? The total time it's spent on the trip was the time it's spent moving 1/3 of an hour plus for 6 times it stopped. And that's what we're solving, is how long the stop could be. Now we're going to figure out when that equals 36. And x will be in hours. And I'm not going to go any further. But we solved that for x. That would be our answer for what the stop could be when it was exactly 36. If our stop was shorter than that, then the average speed would have been more than 36, and we'd be fine. That's the longest the stop could be, x. Last one, 16. Alyssa, 16.
Find all triples of consecutive integers such that 11 times the largest of the integers is at least 46 more than the product of the other two.
Is at least, is greater than or equal to. So here are my consecutive integers. It says 3 of them, right? N plus 1, n plus 2. They're not odd or even, they're just integers. And it says 11 times the largest is at least what?
Is at least 46 more than the product of the other two. So
Okay, so how do I write that?
and then of the quantity or time, n plus 1 plus 46.
Plus 46. And that ends up being a quadratic inequality, which you have not learned how to solve. Is that true? Read it one more time, the whole problem.
Find all triples of consecutive integers such that 11 times the largest of the integers is at least 46 more than the product of the other two.
Yeah, I have not taught you how to solve such a thing yet. You have an n squared here. You don't have one there. It's quite difficult, but I'll teach you in time. I don't think you have it on.
Wouldn't that be minus 46?
No, this had to be at least greater than or equal 46 more than that. This had to be 46 more than that. That's what the words were. It had to be 46 more than that. Doesn't it say it has to be at least 46 more than that? To be at least something, you're equal to it or you're greater than that, right? You have to be at least 16 joules to draw it, so you're greater than or equal to 16. All right, you can stop the video and you guys have